Hello, my name is Tobias Hohmann. I'm a team manager for research and development at FFT's headquarters and the project leader for the research project OptiWAL. Today I would like to give you some insights into our exciting project. The Project OptiWAL focuses on simulation and AI-based optimization of aluminum spot welding processes for lightweight solutions. The project is funded by the German Federal Ministry for Economic Affairs and Energy under the Technology Transfer Program Lightweight. Our project partners include MPA Stuttgart, Form and Test, PVA Tepler, as well as Bosch and AD for data analysis. Our main goal is to improve the resilience of spot welding processes for novel aluminum alloys. This is a crucial step towards lightweight design and improved efficiency for future vehicles. To achieve this, FFT developed, manufactured and commissioned a fully automated welding and testing plant with the support of our project partners. All process and inspection data are captured using our innovative software solution FFT Trace and then used for AI-driven analysis. But now, let's take a look behind the scenes. In the beginning, the robot picks up aluminum sheets from different magazines. Various alloys can be introduced here, which is essential for setting up the welding process. Each sheet is marked with a DMC code and scanned to ensure complete traceability. Before welding, an adhesive is applied to simulate real conditions in production. Gluing is followed by our core process, aluminum resistant spot welding. In this station, all process parameters are systematically adjusted to explore the limits of the joining technology. After welding, we inspect the surface deformation resulted by the electrode pressure. A novel optical sensor developed by FFT performs a topography check to provide insights into the quality and the core diameter of the welding point. Ultrasonic testing performed by PVA Tepler then reveals the internal structure of the weld. This allows us to detect even the smallest defects. After ultrasonic testing, the parts are carefully dried to prevent corrosion and damage to other plant components. The aluminum sheets are then cut into individual shear test samples and are provided to the robot for further processes. Each sample will be tested mechanically. The shear tension test performed by Form and Test gives us insights into the mechanical characteristics of a single spot weld, such as a required load for breaking the weld. Finally, we analyze the broken surface by an optical sensor from FFT. All data from these steps are recorded by using FFT Trace and analyzed by Bosch and AD with AI and big data methods. In addition, MPA Stuttgart is also supporting due to the development of novel FEM models for simulation. This enables us to understand interactions between material and welding process. The aim is to predict weldability and the necessary welding parameters for new aluminum alloys. This reduces physical tests, increases efficiency and accelerates the development of lightweight solutions. I would like to thank all project partners for the great collaboration to achieve the project goals. Thank you for watching. We hope you enjoyed this insight into our project. If you would like to learn more about OptiWAL or further research activities of FFT, feel free to contact us. We are looking forward to get in touch.